All right, so typically when we're collecting data, we want to ask a certain question. We can take a survey to a whole bunch of people and then collect that data, and then we can take the data that's given to us and we can put it on lots of different types of graphs. So we can do a dot plot, we could do a histogram, we could do a pie chart, box and whisker, stem and leaf, bar graphs. So for those of you taking stats, you'll do all those kind of graphs. Okay, you'll find a survey that you want to send out to people, and then you'll collect the data, you'll plot it all, and then you'll analyze it. And so we're just going to be looking at dot plots in this class. All right, so we can look at different shapes of a dot plot. Now, if we're looking at shapes, we're looking at collecting data for like thousands and hundreds of thousands and millions of surveys. So that's typically how the shapes kind of break down when we collect a lot of data. So a symmetric shape, we're collecting data, and we can see that the bulk of the data kind of falls right here. So let's say we're taking a survey of people's heights, how tall they are. All right, and so we can see that the average height, most people are going to fall probably right around here. So let's say the average we calculated, and it's, let's say, 5 feet 7 inches or 5 feet 6 inches. Most people are going to fall right here. Now, as people get taller, okay, so now we're at like 6'5", really tall people, they're going to be over here. There's not as many, okay? And then over here, the really short people, okay, so let's say 4'8", okay? As you move to the left, they are getting shorter and there's not as many. But the bulk of the survey, okay, the data will fall right around here. So this is called a symmetric distribution when that occurs. We also call this like a bell curve. Okay, so have you ever heard of the term bell curve? Okay, it kind of looks like a bell. All right. If we were looking at test scores, okay, so I can give a test, I can look at the data, I can look at the average. Okay, this is basically where the average falls. All right, and then you get really high grades over here. Let's say the average is 70%. Let's see, that's where most people are going to fall, right around here. Now you're going to get some people in 100% or higher, okay, not as many. And then you're going to get some with Fs, okay, again, not as many, right? But the bulk of the data will fall right around here. All right, so that's what a symmetric distribution looks like. Now, a right skewed distribution, okay, looks something like this, where on the right side, this is called the tail of the distribution. Okay, the tail is on the right side. That's why we call it right skewed. So typically, we're trying to get everything symmetric, right? And so the bulk of the data falls right around here. So let's say we were talking about test scores. Let's say I gave a test, and most people, let's say, failed, right? So let's say the average was, 40%. So most people are getting, low scores. They're over here. But then, a couple people take the test, and they score really high. So they get 100%, right? Because they took that test, they got like 100%, it skews the data. It looks like, everybody's failing, but then you get these people that did really well, and they move the average, okay? So the average would be over here, but now because these people scored really, really well on the test, it moves the average up, right? And so because it's moving it to the right, or up, it's a right skewed distribution. And then the opposite happens on the left skewed distribution. All right, so the tail is on the left side this time. All right, so again, if we talk about test scores, they gave a test and everybody scored really well on it, 90s and higher, and all of a sudden there's a few people that were absent. They come in and take the test, and they fail the test. Well, it's going to pull the average, okay, the average score down, okay, so it's going to pull it towards the left side. Because you want to think of this as a number line. Numbers on the left side are smaller than the numbers on the right side. So the average gets pulled to the left, and we call that a left skewed distribution. All right, so we're going to go ahead and create a dot plot given these 12 players' batting averages. All right, and so for each score, we put a dot above that average. And then we can describe the shape of the graph, and we can find the mean, median, mode, and range of the data also. All right, so this is why you want a calculator to do all this. All right, so let's go ahead and create this dot plot. All right, so 0.255, okay, put a dot for that one. You just go through and put a dot for each one. All right, so there's our dot plot. Now, what I always do is I want to verify that I plotted everything. So I just go through, count all my dots, make sure that it's equal to the number of data points that they give us. All right, so they already tell us there's 12, so I should have 12 dots. And if I don't, then I have to go back and check. Did I miss one, or did I put an extra one? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that's 12. All right, so it says describe the shape of this dot plot. So this looks like it's a left skewed distribution. All right. So you can kind of see the tails on the left side. All right, so now we want to go ahead and calculate each of these values. All right, so the mean, what's another name for mean? Average, right. Average. All right, so average. And how do we calculate the average? Yeah, good. So we add them all up, and then we divide by how many data points that we have. Okay, so we're going to add up each of the data points and then divide by 12, right? Because there's 12 players. Right? So go ahead and do that and make sure that you can put it in your calculator correctly. So again, we're going to add them all up and divide by 12. So when you're inputting this stuff in your calculator, it's really easy kind of to take it from your dot plot. Okay, so here, the way I would probably put it in is 0.255 plus 0.26 plus 0.265. Now, when you come over here, instead of having to hit 0.275 3 times, you can just do 3 times 0.275, right? And then plus 4 times 0.28 and plus 2 times 0.285. So you put it in that way, it's less inputting, and you know, you don't have to go back and check to see did you miss one by putting each data point in. All right, so when you add them up, it should be 3.295. And then when we divide that answer by 12, it's going to be 0.275. So that's our mean. All right, the next we want to find is the median. All right, so how do you find the median? Yeah. Good, it's the middle number. So median, kind of think of driving, left side, right side, there's a median in the middle, so it's the middle number. Now, it's the middle number when it's ordered from smallest to biggest. So if it's not ordered smallest to biggest, you have to rearrange all the numbers. Okay, so you got to order from smallest to biggest. And so it's the middle number. Now, if there's an even number of data points, then you have to take the 2 middle ones and add them and divide by 2. So you have to take the average of the 2 middle ones when there's an even number of data points. When there's an odd number, then there will be a definite middle number. Right. So there's 12 numbers, so that's an even number. So as this is already ordered from smallest to biggest, so you can just start counting in. Okay, you're going to come in 6 to the left and 6 to the right, and the 2 middle ones, you're going to take the average. All right, so our middle 1, 2, 3, 4, 5, 6. And then counting up from the right side, 1, 2, 3, 4, 5, 6. So we're taking the average of 0.275 and 0.280. Right, so take the average of those two. All right, so that should be 0.2775. All right, so the next we want to find is the mode. And so what's the mode? Yeah, the one that has the most. So mode, think of most. And so we can really see it easy on a dot plot. It's the one that has the most dots. So right there. So 0.28. All right, and then the last we're going to calculate is the range. And how do you find the range? Yeah. Yeah, good. It's the biggest one minus the smallest one. Okay, so it's the range of data. So largest minus smallest. All right, so we're going to take 0.285 minus 0.255, and so that should be 0.03. That's our range. All right, and then D says, which is larger, the mean or the median? Which one's larger? Yeah, the median. Okay. So that one's our largest one. All right, now we can see this on this distribution. So 0.2775 is about right here. Okay, so this is our median. Okay, and then the mean, show that real quick. The mean is 0.275. It's right here. So we can see that the mean is on the left side of the median, or smaller than the median. And so this is going to be an important concept where if it's a skewed distribution, the mean is going to always be on the same side as the tail, right? And so this is a left skewed distribution. The mean is on the left side of the median. Okay? So the mean is always on the same side as the skewed. And that's because the average would be right here, but because of these numbers out here, these really low scores, the mean got pulled to the left, got pulled down. All right, so when we have these different shapes, a symmetric distribution, again, this is our bell curve. So when you have a symmetric distribution, the mean, median, and mode will basically be in the exact same spot. Okay, they'll almost be equal. They're right there in the middle. All right, so generally we say the mean is equal to the median. Now on a right skewed distribution, okay, most of the data is on the left side, so this is where the median is located, generally. And then the mean is going to get pulled in the direction of the skew, so the mean will be on the right side of the median. Okay, so on the right side of the median, or we can also say the mean is larger or greater than the median. All right, so the mean is going to be on the right side. And then the opposite happens on a left skewed distribution. All right, the median will be about right over here somewhere. The mean will be on the left side. All right, so the mean is on the left side of the median, and so the mean will be less than the median. Again, just think of this as a number line. Numbers on the right side are bigger. Numbers on the left side are smaller. All right, so again, that's what this is talking about. The mean is generally pulled in the direction of extreme values, called outliers. That's why it affects the speed. All right, so let's do this last one. So again, we're going to create this dot plot for these ages of 10 teachers. We'll create the dot plot, and then we'll answer each of the questions below.